There's a specific kind of genius that I think, well, it goes totally underappreciated in the modern world.
Yeah.
It's not the genius of inventing something brand new from scratch, like, I don't know, the light bulb or the iPhone. It's the genius of the remix.
A remix, you mean like in music?
Sort of, but applied to everything. It's that ability to look at two completely distinct, unrelated systems worlds that have absolutely no business talking to each other and just smashing them together to solve a problem.
Nice.
Like looking at a fish tank and a vegetable garden and realizing, hey, these are actually the exact same machine, just tuned to different frequencies.
That is the tinkerer's mindset in a nutshell.
Yeah.
It's pure pattern recognition. You aren't inventing the components, you're just realizing the component A plugs perfectly into socket B.
Even if nobody has ever tried it before.
Exactly.
And that is exactly where we are living today. We are doing a deep dive into a really fascinating, slightly obscure, but incredibly instructive corner of the internet. We're looking at a set of notes from a blog called qianmeng.org.
Which is such a great find, by the way. It really feels like stumbling into someone's digital garage where they keep all their half-finished inventions.
Totally. The specific entry we're dissecting today is titled Notes on Fishkeeping, Part 177. And honestly, that number alone, 177, it just stopped me in my tracks.
It implies a massive data set, right?
Yeah.
It tells you this isn't a casual diary where someone writes, 3 posts and quits.
Not at all.
This is a long-term research project.
Exactly. This particular update was published recently, January 21st, 2026. The author describes himself with a phrase I absolutely love.
What's that?
An old software plumber.
Huh. That is such a vivid persona.
Yeah.
You picture someone who has spent decades in the trenches of back-end code-fixing leaks, optimizing pipelines, dealing with messy legacy systems.
And now he's taking that same brain, that software plumber logic, and pointing it at nature, specifically at his aquarium.
Right.
So the mission for this deep dive is pretty specific. We want to understand how this software engineer plans to turn a common houseplant into a high-performance biological machine for his fish tank.
And crucially, we need to talk about the engineering bugs he's finding in the hardware. Because, as any engineer knows, it's not as simple as just sticking a plant in water and hoping for the best.
Right. So let's start with the catalyst. Because usually when we buy plants, we are kind of running on autopilot. We go to the nursery, we see a pot, check the price, we buy the pot. But our author, he sees something different.
He's walking through a nursery, just a standard shopping trip, and his pattern recognition software just kicks in. He spots a Philodendron Burle Marx.
The Philodendron Burle Marx, which for those who aren't, botany nerds, is that low-growing, clumping plant you see in office lobbies everywhere.
The default office plant.
Exactly, usually sitting in a pot of dirt.
Usually. But that's the glitch he spots. At this specific nursery, these plants aren't in soil. They're sitting in plastic aquarium tanks with their roots completely submerged in water.
No soil at all.
Zero soil. Just water.
See, most people would walk past that and think, oh, the staff is just soaking them, or, hey, that looks neat. But the software plumber stops. He analyzes the input. What does he see?
He sees a successful test case. He realizes this isn't just a display choice, it's a propagation method. The nursery is growing them this way on purpose.
To make more plants.
Right. And if the nursery can keep the plant healthy with wet feet, permanently wet feet, it proves that the hardware, the plant, is compatible with a totally different operating system.
The aquarium. It signals compatibility. It's like realizing a piece of software written for Windows actually runs perfectly on Linux.
And that leads him to the concept of the riparium.
Yeah, and we should probably pause on that word. I've heard of aquariums. I've heard of terrariums. Riparium sounds like the name of a bad sci-fi planet.
It does a little.
We need to define this.
It's actually Latin-derived. Riparius means of the riverbank. So a riparium is a tank setup that mimics the edge of a river.
Okay.
The key feature is that the plant's roots are underwater in the tank, but the foliage, the leaves and stems, is up in the air, above the surface.
So it's the mullet of the plant world. Aquatic in the back, terrestrial in the front.
That is surprisingly accurate, yes. Yep. But functionally, it's a bridge between the water and the air. And for a fish keeper, that bridge is a huge opportunity.
An opportunity for what?
It lets you tap into the power of terrestrial plants to clean your water.
Okay, so he knows the plant can survive the water. That's the nursery observation. Yep. But just because it can survive doesn't mean you should put it in your tank. Why is he so fixated on this specific philodendron?
This is where we have to switch from looking at the plant as decor to looking at it as a device. In the source notes, the author zeroes in on two specific specifications of the Burle Marx.
What are they?
First, the root system is expensive. Second, and this is the big one, it is a heavy feeder.
Heavy feeder. Sounds like me at an all-you-can-eat buffet. But in a botanical context, I assume we aren't talking about calories.
We're talking about nitrates and phosphates. And to understand why that matters, we have to look at the invisible war happening in every single fish tank.
Let's unpack that, because I feel like nitrates is one of those words people hear constantly in pet stores but don't actually know what it means.
Sure. So here's the quick version of the aquarium loop. Fish eat food, fish poop. That race breaks down into ammonia, which is toxic.
Right.
Then bacteria turn that ammonia into nitrates and then into nitrates. Nitrates are less toxic, but if they build up, they stress the fish.
It's pollution. It's like living in a room where the air quality just gets worse and worse
Every
more.
single day.
Ag.
Exactly. It's dissolved smog. Now, usually you get rid of nitrates by changing the water. You physically bucket it out.
Oh, a water change.
But nature has a better way. Plants eat nitrates. To a plant, nitrate isn't pollution, it's fertilizer, it's lunch.
So the fish poop is the plant food, the circle of life.
Precisely. But here's the catch. Algae eats nitrates too.
Ugh, the green soup. The bane of every fish keeper's existence.
Right. If you have nitrates in your water, something is going to eat them. If you don't have a plant doing it, algae will volunteer. It's a vacuum that nature tries to fill.
That's a race. It's a competition for resources.
It is a zero-sum game. And this is why the author loves the Philodendron Burle Marx. When he calls it a heavy feeder, he's saying it is an aggressive competitor. It grows fast, it has a massive root surface area.
It sucks it all up.
It sucks up nitrates and phosphates like a high-powered vacuum cleaner.
So effectively, by installing this plant, he is starving the algae to death.
That is the goal. He explicitly notes that the plant helps to suppress algae growth. He's not buying a pretty leaf. He's installing a biological filtration unit that runs on fish waste.
I love that framing. It's so efficient. It's remarkably similar to how you'd optimize code. Why run a separate process if you can just integrate it into the loop?
Exactly. It's elegant. It solves the problem at the source.
But, and here is where the plumber part of software plumber comes in. Theory is perfect, but reality is messy. Reading through these notes, you can practically feel the author frowning at his monitor.
He loves the biology, but he hates the physics.
Yes, the implementation phase. This is where the project usually stalls. You can have the best software in the world, but if the hardware casing melts, you have a problem.
And he says it plainly, right? I still can't visualize an effective way to secure them.
That is the engineering challenge. We have to look at where he wants to put this. He mentions outdoor ponds and a front yard balcony, so we aren't talking about a tiny jar on a desk.
No, we're talking about a volume of water, probably with a rim. And the problem is the plant itself, the way it grows. The Burle Marx isn't a vertical tree that grows straight up.
Right, he calls it a creeper.
It's a creeper. In the wild, it crawls along the forest floor or up tree trunks. It wants to spread horizontally. It has wanderlust.
So just imagine the physics of this. You have a plastic basket, which is what is usually used, hanging on the edge of the tank. You put the plant in, it starts to grow.
And it starts to creep away from the basket. The center of gravity shifts.
It's a lever problem.
It's a simple lever arm problem. As the plant extends outward, the torque on that little plastic clip just increases and increases.
And the author spots this failure mode immediately. He writes that it will eventually outgrow its initial placement.
And he's worried about the supporting thin plastic basket. He knows that plastic degrades in sunlight. It gets brittle. He knows the plant gets heavy.
Biomass has weight.
And if that basket snaps, or if the whole thing just tips over from the weight,
Splash.
your biological filter is now swimming with the fishes and rotting, which releases all those nitrates right back into the water.
Total system failure. Basically becomes a nitrate bomb instead of a filter.
Exactly. And what I find so compelling about this source is that he hasn't solved it yet. He identifies the bug, structure cannot support projected load, but he doesn't have the patch.
It's refreshing, honestly. Most content we consume is, look at this perfect thing I built. Look at this problem I'm scared of.
It's the planning phase. And to really understand why he's approaching it this way, we have to zoom out and look at the tinkerer's context. You mentioned he's a software plumber, but did you look at the sidebar of this blog?
Oh, I did. And it is. It's overwhelming. It made me feel very unproductive.
It's a lot, right?
We're looking at notes on fish keeping, part 177. But then I scrolled down and saw notes on gardening, part 783.
783.
That is an insane amount of data. That's years of documentation.
And it's not just fish and plants. Look at the other tags. Haskell, Python, Rust, Go, Elixir.
All programming languages. And not easy ones either. Haskell and Rust are serious, complex systems languages. These aren't things you just learn in an afternoon.
And then notes on dieting, notes on photography, notes on meditation, notes on guitar.
This is a person who doesn't just dabble, they obsess. But it's a specific kind of obsession.
It's systematic curiosity. Think about how you learn a language like Rust. You have to be rigorous. You have to understand memory safety, ownership, concurrency. You can't just guess. He is applying that same rigorous framework to his balcony pond.
It's the scientific method, disguised as a hobby. Observe, hypothesize, test, document.
Especially the document part.
Nah.
That's the key. He isn't just doing it, he's writing it down. Notes on Fishkeeping Part 177? He is creating a database of his own experience.
He's open sourcing his life.
For himself, yeah. Which explains the tone of this specific post. He ends it on a cliffhanger. He says, until I obtain a specimen for evaluation, it's still too early to tell.
He hasn't even bought the plant yet.
That's what I love. We are reading his pre-purchase risk assessment. He's standing on the edge of the project, running the mental simulation, calculating the weight of the creeping philodendron versus the tensile strength of a plastic basket. And he's pausing.
It's the wait-and-see approach. In software, you wouldn't deploy code if you knew there was a memory leak.
In his pond, he won't deploy the plant if he knows there's a structural leak.
So let's play devil's advocate. If the structural risk is so high, if the thing is going to tick over, why is he still considering it? Why not just get a lighter plant?
Because the pros column is incredibly strong. He lets them out, and for his specific use case, they are compelling.
What are the big wins?
First, modest light requirements. Remember, this might be on a balcony or a shaded pond. A lot of flowering plants need full blasting sun. Philodendron Burle Marx is an understory plant. It evolved to live in the shade.
So it won't die if it's in a gloomy corner. That's huge.
Huge. And second, low maintenance nature.
The holy grail of hobbies.
Exactly. We all want the result without the work. But seriously, once this plant is established, it practically takes care of itself. It eats the fish waste. It doesn't need pruning every week.
And it doesn't need special fertilizers because the fish provide them.
Right. So he can solve the mounting problem. He's created a perpetual motion machine for clean water.
A lazy man's filter. High reward, high risk of mechanical failure. So the verdict right now is suspended.
Too early to tell. He's waiting to get his hands on the physical specimen. He needs to feel the weight of it. He needs to see how fast it actually creeps. He can't simulate that part. He needs to touch the hardware.
You know, looking at the timestamps on his blog, he posted dozens of times in January 2026 alone.
He's moving fast.
We might find out next week if he figured it out. Or if he abandoned it for a fern.
That's the reality of the tinkerer. You have to be willing to kill your darlings. If the data says this won't work, the software plumber deletes the code and starts over. He doesn't get emotional about the plant.
I think that's a great lesson for any hobbyist. How often do we force a solution just because we already bought the parts?
Sunk cost fallacy. He seems immune to it. He's rational about his leisure time.
So let's zoom out a bit. We've spent this time analyzing a guy in 2026 looking at a philodendron. Why does this matter to the listener driving to work right now?
I think it matters because it challenges our definitions. We have these rigid categories in our heads. Technology is silicon chips and screens. Nature is trees and dirt.
And ne'er the twain shall meet.
Right. But here's a guy who looks at a root system and sees a filtration pump. He looks at a leaf and sees a solar panel powering that pump. He is treating biology as technology.
It's about utility. It's about function over form.
Exactly. Biological systems have been solving engineering problems like water purification, structural integrity, energy capture for millions of years longer than we have. The Philodendron Burle Marx has already figured out how to extract nitrates from water perfectly.
We don't need to invent a machine to do it. The machine already exists.
We just need to figure out how to mount it to the rim of the tank.
That's it. The challenge isn't the chemistry. The challenge is the interface. It's the bracket.
That is the software plumber genius. Taking the hardware of nature, which is open source effectively, and hacking the interface to make it work for us.
And doing it alongside learning Haskell and playing guitar, it just reinforces that learning is universal. The critical thinking skills he uses to debug a line of Rust code are the exact same neural pathways he's using to debug his pond.
It really makes you look at your own hobbies differently. I'm thinking about the listeners. Maybe you're a knitter, or a baker, or a mechanic.
Right. If you bring a mechanic's brain to baking, do you start seeing the dough as a material stress test? Do you invent a better oven?
You absolutely do. If you bring a coder's brain to gardening, you get a riparium. You get automated irrigation systems, you get efficiency.
It encourages us to cross-pollinate our interests. Don't silo your skills. If you're good at spreadsheets, use that to optimize your marathon training. If you're good at painting, use that to visualize your data analysis.
And document it. That's the other lesson. His notes are valuable not just to him, but to us. We are learning from his unfinished experiment.
Notes on Life, Part 1.
Exactly. Start writing.
So we've covered the biology of the heavy feeder, the physics of the creeping plant, and the philosophy of the software plumber. It's a lot to extract from one short blog post.
It is, but it's a great example of how much depth is hidden in the mundane. A plant in a plastic cup can spark a whole conversation about engineering.
As we wrap this up, I want to leave the listener with a final thought. Bit of homework, if you will.
Oh, we're assigning homework now.
Just a mental exercise. We've been talking about the Philodendron Burle Marx as a filter, a tool, a machine made of leaves.
Right.
So look around your house, look at your garden, or even your office. If a software plumber can look at a decorative creeper and see a nitrate scrubbing engine, what other biological tools are you overlooking just because you've labeled them as ornamental?
That is the question. Is your lawn just grass, or is it a heat sink for your house? Is that spider plant just decor, or is it an air purifier that you haven't optimized yet?
Are you utilizing the technology growing in your window, or are you just watering it?
There's only one way to find out.
Start tinkering. Start documenting. And maybe, like our friend Ang, share your notes with the world.
Even if it's just part 1 of 700.
Exactly. Thanks for joining us on this deep dive. Keep hacking your ecosystem.
Keep exploring.